What's up, guys? Another training video here. This one we're going to talk about some of the basic electrical stuff that we're going to be troubleshooting on air conditioners and furnaces, and I'll even pop up over to some of the commercial stuff to give you a quick idea on some of that stuff as well. Again, not trying to train you guys how to check electrical right now. I just want you guys to watch this video, get comfortable with some of the components that we're going to be concentrating on. That we'll really hammer in class. So in class we'll figure out what they all do and how they work, but this video is just gonna give you an idea of what we're looking at. So get familiar with the names and where they're located in the system. So when we do get out here into the lab, start troubleshooting stuff, you already have an idea of where the stuff's at. All right, let's get started.
All right. First one we're going to start with is the plain Jane air conditioner. Okay, it's about as basic as it gets electrically. All right. Every air conditioner is going to have a couple of major components. I mean, heat pumps are going to have these too, but there's a lot of stuff that heat pumps are going to have that air conditioners just don't. Okay, so that's why we're starting here. We're going to have a condenser fan motor. Okay. Big electrical, lots of electrical problems happen with these. These are a very common failure. Okay, right here. In order to get that, a lot of the units are different. Sometimes they just have this center part will pop out to get it. In this case, this one I have to take off the whole top and flip it over. And I've actually taken one off over here so you guys can kind of see what that looks like. But we just flip it upside down. Pretty basic fan blade. Single speed motor most of the time. All the information you'll need to know should usually be on the nameplate. Horsepower, what type of capacitor it's going to use, everything like that should be labeled right there. But for those of you that took refrigeration, I mean, this is the fan that's moving our air across our condenser coil to cool that compressed superheated vapor, cool it back down so it condenses into a liquid and then subcools. We're using this guy here, this condenser fan, to pull that air over that coil to make that happen. Okay, this is a very, very common change. Especially if you're a residential guy, you go that route, you're going to change this a lot. It's a very easy repair. Again, we'll do it 100 times out here, but that's our first component, condenser fan. Second one's going to be the compressor. So I have the top off of this one. So this air conditioner that we were just at, it's going to have the same thing. All these heat pumps all have them. Our compressor. And again, for you guys that learned about refrigeration, we're taking our superheated vapor from our evaporator, we're compressing it in here into a superheated compressed vapor, and so it can come into the condenser and condense back into a liquid. But this is our compressor right here. This is a scroll compressor. Again, we'll talk about the different types of compressors, and they all do the same job, but how they accomplish the job is a little different. This is a very common one though, especially in residential. You're going to find a lot of scroll compressors. Okay, compressor. Come back down here to the plain Jane air conditioner. We got a bunch of wires and stuff in there. Okay. Component wise, this is called a contactor. And just so you guys know, for safety reasons, and again, we'll go over lots of safety and everything, I have the power off, the disconnect off, and I have verified with my multimeter that there is no power here. So you guys just don't think I'm in here jabbing around on 240. Okay, but this is our contactor. Our contactor, we hook high voltage up to it. We also hook low voltage up to it. And based on the low voltage signal that it gets from the furnace, which comes from the thermostat, we'll tell this contactor to close or open. When it closes, we're going to pass the high voltage power through that contactor into our condenser fan motor and our compressor, which we just looked at. So this is a control for our compressor and our fan motor. So this ultimately determines whether this condenser comes on or turns off, based on what the thermostat, with the low voltage signal, what the thermostat tells it to do. This here is our capacitor. It looks like a big battery, right? Well, it kind of is a big battery. It's a little different. Again, we'll learn about it, what it does. But that is a capacitor that's hooked to our condenser fan motor and our compressor, and helps them not only start, but run more efficiently after they start. This, my friends, in the summertime especially, is going to be your most common repair, especially if you're residential. You will change thousands of these throughout your career. This is the weakest link in the system. Heat beats these guys up. So the hotter it gets outside, the more of these fail. And when these fail, these motors can't start, the condenser and the compressor can't start. And if they do start, they run really hard. And sometimes, especially with the condenser fan, it will run the wrong direction if this capacitor has failed. But that is a starting component for the for the condenser fan and the compressor, and it also stays in the circuit while it's running to help it run more efficiently, those two motors. Super common repair. You'll make this repair a lot. This is also a common repair. You'll change this a lot. Contactor, capacitor. Let's move on to our electric furnace. Lots of wires in there. Okay, these things up here, these are our safeties and for our heat strips. Again, this is an electric furnace, so we're heating the home with electric heat strips that are on the other side of these safety switches. Come on over here to this is an old electric furnace that's been pulled out, but with the ductwork off, we can actually see behind the electricals in here. But we have the ductwork pulled off so we can actually see the heat strips. These are the backs of those safeties. And we'll learn how safeties work. But these are electric heat strips. We just put 240 volts to these things. They're just a big resistance heater. They glow red hot, and we gotta move air over them or they'll overheat. And then there's heat transfer. The air that we move over it, and the electricity or the heat energy that we're creating with the resistance of these, we have heat transfer, and that's what heats our house. They just look like big bed springs. Heat element, electric heat strip. To control those, we have what we call a stack sequencer. And again, I've verified that the power is off to this. I also have my breaker off, and I have tested the power with my multimeter. This is a stack sequencer. Get that red wire out of the way there. The reason it's called a stack sequencer is because there's actually two switches. Let's see if we can get in there a little closer. So you can see there's one switch here, and there's another one down there. There's two heating elements inside this. So there's two switches on the stack on the sequencer. The sequencer will bring those heating elements on in a sequence, meaning they don't come on at the same time. If everything works right, you'll have the blower motor and the first element will come on together, and then second element, third element, fourth element, however many elements you have in the system will come on in a sequence. And they'll also turn off in a sequence. The sequencer does that. It's a control. It does high voltage we have high voltage wires right here. These red and black wires to control the strips. And then and then also has low voltage. It's going to get a signal from the thermostat to tell those switches to close or open with the low voltage signal. And when they close, they'll pass high voltage to the strips,
or when they open, they'll cut high voltage to the strips and the strips will turn off. Stack sequencer. Same concept as the contactor. Uses the low voltage signal from the thermostat to open or close based on what the thermostat is telling it to do. When they close, they'll pass the high power through and to the motors. Same thing here. Low voltage signal, it will close and pass high voltage to the strips. Those strips will come on and we're heating the house. The low voltage signal goes away, meaning the thermostat's telling them to turn off. Those switches will open, will cut high power to the strips, and our heat will turn off. Stack sequencer. I think we're all familiar with this. This is just a breaker. 60 amp breaker. The reason this is a 60 amp breaker is because when these things are running, these heating elements, they're going to run roughly about 20 amps a piece. So if we have two elements plus a blower motor, we're going to be running about 45 amps. So we want to have, at least we only want 80% of our circuit. We have to have a little bit, we have to have about 25% more capacity. So we have the 60 on here. But if we have a short circuit situation, which we'll learn about, this will pop and cut the power off. This is your blower motor. Again, for you guys that took refrigeration, this is what's moving our heat. This is what's moving our room air over our evaporator coil and also our heating strips. This is the housing. This isn't the actual motor. You can see the electrical side of the motor sticking out right here with the wires that go up here to the board, and that's how we control the speeds. And we'll come in here a little closer. You'll see we have the blower wheel and the shaft sticking out the other side there. We're going to change this a couple of times during this next electrical mod. Okay, that's our electric furnace. Let's move over here to our gas furnace. A little bit more going on here. Okay, we still got our blower motor. We also have a control board in here, controlling all the gas safeties and everything like that. Here's where our thermostat plugs in. This is our thermostat wire. It's a low voltage wire. It's thinner. This guy here, this is going to be really important to remember what this is. This is our transformer. This is taking 120 volts in this situation. Gas furnaces only use 120 volts. And it's taking that 120 volts and stepping it down to 24 volts so that we can power our thermostat and our low voltage controls. Over here, the transformer is kind of hidden. This is our electric furnace again, but the transformer's there behind this board. It's kind of hidden. Same thing. The only difference with this one is electric furnaces are 240 volts. So it's taking 240 volts and stepping it down to 24 volts for us to power our thermostat and our low voltage control wires. Most blower motors inside these furnaces are going to have a capacitor. I'm not going to take that guy out, but you can see the top of it there. Just like the one over here that we talked about in the air conditioner. It's the same thing, it's just running the blower motor inside here. Let's go back over here to the electric furnace. This one actually doesn't have one because this is a ECM motor. And we won't get into that now, but it doesn't need a capacitor. Moving on up into the so this is the actual heating chamber, the gas furnace chamber here. This is our inducer motor. This is a small motor. And the small blower wheels inside here, and its job is just to take the fumes, the stuff that we produce while burning gas, so the bad stuff. It takes it out of the heating chamber and out the exhaust pipe. These aren't super common failure, but you will change a lot of these in your career too, especially if you're residential.
gas valve. This is powered by 24 volts. This controls the gas flow to the burners. Pressure switch. These guys have 24 volt signal. They will open or close based on whether this motor comes on. So they're essentially a safety. We want this motor to come on. If it doesn't come on, this switch won't close and the furnace won't start. Of course, our thermostat, we're going to learn how to program this. We're going to learn how to wire it for the different applications, for heat pump, for gas furnace, for plain air conditioner, for electric furnace, for 3 stages of cooling, 2 stages of heat, or 3 stages of heat, 2 stages of cooling, excuse me. We're going to learn how to program all of that. We also have our touch screens. These are very common as well. But we're going to learn how to do all that. Now these two here that you'll see in the lab, these 2 heat pumps, you'll notice that there is no contactor in there at all. There's a capacitor, but all the control voltage and everything runs through this board. So in this mod, we're not going to spend a lot of time on this particular heat pump, just because it's a little bit more complex. But over here in this heat pump, we have our contactor. There's our capacitor. The difference in this between that air conditioner that we were just looking at is we have a defrost board. And for those of you that took refrigeration last mod, you're going to remember that in heat pump mode, when it's running and heating, the coil is going to frost up, and we need to send it to defrost every once in a while to keep that frost from building up. This board is controlling all that. Again, not a super common repair, but you will learn how you're going to have to make these repairs a lot as well. You're going to have to change these out. A lot of the times these set outside, these condensers. So what I've ran into a lot of the time is right behind this board. See, there's a nice space through there, but a lot of times what happens is spiders and stuff will crawl up in there and build their nests and stuff because it's nice and warm. And all those little solder joints there, we get enough spider webbing back in there, and it makes an electrical connection from the board to the case of this heat pump and shorts this board out. And we got to change that board. But that controls our defrost cycle.
Okay guys, so that's most of the really common stuff. We're going to touch on all that in class. We're going to learn what it does. We're going to learn how to test it. We're going to learn what voltages they run at, what amp draws we should be seeing on that stuff. But hopefully this gives you a good idea of where to locate those items in the system. So when we start class next week, we come in our first class, you guys already have kind of an idea of what we're looking at. Again, not necessarily how to check it and how they work, but physically what they look like and where they're located. That's really going to help us a lot get started. Okay? All right, see you next week.